So welcome, thank you for coming to my talk, and maybe actually today I'm gonna talk about macOS caches, the thumbnail cache specifically, but also the notifications center cache. But at the beginning, I just wanted to introduce myself. So this is my third Blackhoodie. I came to Blackhoodie for the first time 2 years ago, and I loved it. So now I'm trying. Now I want to give back a little bit and talk about my research that I have done for my bachelor's dissertation. And yeah, I finished university in May. I studied cybersecurity and forensics, and now I do DevOps and security engineering, and I live in Edinburgh, Scotland. So let's start. So for anyone who has a Mac computer, you will be able to kind of look into your own machine and see all of these things. So most cache files and cache directories are, not all of them, but most are located in the var folders directory, and then you'll have a random string, that's the name of another directory, and then inside yet another random string that will stay the same obviously in your own system, but you kind of have to find it on your own the first time you look there. And then you will find three directories: C, 0, and T. So C are the caches, T stand for temporary files, and 0 are some other system files. I'm not exactly sure why it's called 0, couldn't find that. And there's a great blog post which details everything, like all of the other details and other caches that you can find in var folders. And this is the blog. It's called Magnus Viri. And if you want to learn more, feel free to Google that blog post. But I'm going to focus on thumbnail cache and the notification center cache. So basically, I started, because I studied cybersecurity and digital forensics, my dissertation was focused mostly on the digital forensics bit. That's why I looked at thumbnail caches and the application of what you can find there, you know, how you can treat these things as digital evidence and stuff like this. So that was kind of the academic part, whereas the notification center is more fun, and I guess will be more interesting just for everyone who's into hacking. So let's look at the thumbnail cache first. This doesn't work, so I'm just gonna click here. Okay, so first, what are thumbnails? I'm pretty sure everyone knows, but there's just a one little thing that I want to mention is that thumbnails are created, at least nowadays, not only for images, as you would think that that would be the only application, but for everything really, for text documents, for Word documents, for PDFs, and the thumbnails are smart enough now that you can, when you have a PDF and you look at the thumbnail, you can see kind of the shape of the text. So it's not only like, you know, not only a picture of a document or a white page. It will actually reflect what's inside of it. So that's already can give you some information. If there was a picture in the PDF, you would see the picture. Maybe if the resolution was good enough, you could actually kind of see what's in the picture. And all operating systems have, I mean, all the mainstream, I don't know about all of these obscure little ones, maybe some don't have them, but Windows and Linux and macOS all have thumbnails and thumbnail databases. But macOS has an additional kind of functionality, which is called QuickLook. So if you select a document and you press space, then you get like a preview of a document. It's quite big. You can read all of it or see the whole picture. And I think if you do that to a video, it will even play a little bit. But it doesn't count as opening the file, so that's important. It's still a preview, and that's also part of like the thumbnail mechanism. So now let's look into what the cache actually looks like. So on the left you can see the C directory, the cache directory. There's a number of different ones for different applications like iBooks or iCal or icons in macOS. And if you go into Com, Apple, QuickLook, thumbnail cache, you can see a number of SQLite files, and the ones we are interested in is the index.sqlite, and that's the database where we can find all the metadata about the thumbnails. So the actual files are located in thumbnails.data, but thumbnails.data is just a data blob, so these will be the PNGs that are the actual thumbnails, but you can't really carve anything out of there because they don't have the file signatures. So unless you have the metadata from the database, which tells you the offsets of where all of the images start, you won't be really able to do much with the data file on its own. So that's why we're going to look into the index.sqlite. One more note is that each user on a system will have their own thumbnail cache, and when you're an admin, you will be able to access all of the users' caches. So that's going to be important when you think of what you can do with this information. So let's look into the index.sqlite. We can look at the tables inside that database. So we have the files table and the thumbnails table, and they both will have metadata about the files that the thumbnails were made for and the thumbnails themselves. So there are some other tables as well, but with all of my experiments, I could never get anything to be saved in there. So that's still, for me, unknown what's exactly in there. So if we look at the files table, obviously we'll have the path, the folder where the file is located, the file name obviously, and the kind of file ID, which will tell you the volume ID where the file is and the file ID within that volume. So that will be useful if you want to reconstruct users' behavior later. You can see if a file was moved and like where it was moved within a volume. And then the thumbnails table has a lot of different fields, including how many times the thumbnail of the file was viewed and the last time that it was accessed, which is quite important for any forensics that you might want to do with it. So we want to know, as forensics analysts, what kind of a user behavior will make a thumbnail appear in the cache, because if we don't find that, then it's kind of useless, because we can't prove, for example, that someone has seen a file. They can claim that it was just in their, just appeared in their cache. So, because it's quite hard to find any documentation about any of these things for macOS, I kind of had to do experiments of my own, very technically advanced, like moving a file from one folder to another and seeing what it does to the cache. So basically, so an important thing here is that all of this, like, I'm not making this images because I don't think that people know what moving is, but it's important that you have to see the file. So it's literally a UI, like a GUI action that you have to do, because if you do it in the command line, then the thumbnail will not get created because you're not interacting with it, you're not viewing it. So you literally have to drag the file from one folder to another. And then when I look into the cache, you can see that we have 2 entries for the file name to move, so the one that I moved, and both the volume ID and the file ID are the same. So in this way, if a user was moving or copying the file, you could see that it's the same file, even, for example, if the file name was changed. But also, you can see that the cache isn't really that smart. It's not going to like retroactively, change some data for a file. For example, it's not going to rename, like change the folder of the entry that's already there. It's just going to add another one, and we will also like another entry, and we will also see it in an example when you delete a file. And what's interesting, I don't think I have a slide on this, so I'm just going to say it now. The cache of course, doesn't grow indefinitely. When it reaches 500 megabytes, it interestingly doesn't like delete the oldest, the oldest entries or something like this. It just zeroes itself out to 0 and starts from 0. So whenever, like, if you did something and you want to hide it, then you just have to look at a lot of different files so that it kind of pushes the old data out of it. So now let's have a look at moving this hacking image from a USB stick to your desktop. So we're again looking at it, we have to view it and just drag it to the desktop. And when you check the cache, you can see that here all of the, sorry, not all of them, but both of the identifiers changed. So both the volume ID and the file ID, because it's a different volume, and then the file has a different kind of position within that volume because it's not on the same one anymore. But I guess you could still argue that the file name can kind of give you an idea that it's the same file, but you can't really prove it anymore. And here just a quick one, that when you rename a file, it still understands that it's the same file. And here there's an interesting one. When you delete some files, here I just wrote some strings to 2 files and then dragged them to the trash. And interestingly, if you want to delete something and you view it again in the trash, it will make yet another entry showing that it was deleted. So basically, if you really don't want someone to know that you have viewed some files and you put it into the trash, you only make even more evidence that you have interacted with that files. So better just leave it. Okay, so why are we even interested in this at all? So this is quite useful for any digital forensics work, because, as I said, the cache was only 500 megabytes, so it's good for digital forensics triage. It's much cheaper and faster to analyze half a gigabyte than the whole disk of pictures or photos that someone might have. So obviously it's not like comprehensive. It doesn't show you the whole picture, but like if you find something in this, then at least you know that maybe this is worth looking into faster or in more detail. And as we've seen, it's also useful in user behavior reconstruction, and probably as a regular user, you wouldn't think of deleting it, while you could think of deleting the pictures or photos themselves. So you might delete them, but the evidence will still stay there. And also, of course, security researchers have found bugs in this system in the past. So this was in High Sierra. Now, of course, we're at macOS. I think is it Catalina right now, but the research I've done was on Mojave. So anyway, in High Sierra, a Polish security researcher, Wojciech Reguła, found a vulnerability. Here you can scan it, and it should take you to that blog post if you want. Basically, if you put an encrypted USB storage into your computer, viewed some files, and then unplugged it, all of the thumbnails would stay there. So that wasn't very good, because, as I told you before, you could see not only pictures but also text files, and some things were recoverable from there. So that was very heavily covered. There was a lot of articles about it, and then they fixed it in Mojave by just adding a system integrity protection over the cache, which means that you can't view it at all. It's still there, but you can't view it. If you want to view it, you need to disable the system integrity protection at boot time, and then go into recovery mode, then turn it off and reboot again. So you might think, well, how is it useful if you can't go in there anymore? So it is actually still quite useful whenever you are the admin of the system, which you think, okay, well then it's my computer, then what do I care? But a lot of the time I think in like bigger corporations maybe, or universities, like at my university, you would have this kind of a shared workspace model where anyone could log in to any computer just using their I think it's AD credentials or something like this. I'm not sure about the implementation of that, but anyway, a lot of people would use your computers and they wouldn't be admins, so you would have access to all of these caches. And well, in that scenario, you can after they use your computer, you can still access their cache. And also, when you're an admin, you don't even have to log in to their account. You have access from your own. Oh, sorry. Okay, so now I'm just going to briefly talk about the notification center cache. So this is interesting because this doesn't seem to be this is in the zero directory, and it doesn't seem to be protected by the system integrity protection at all. So I was able to access it, like I was even surprised, but I could access it without any restrictions. So again, we have an index, a db.SQLite, and we can go inside of it and see a number of tables. So we will have app tables. From all of this, we are most interested in the app and record tables, and I'll show you in a second what they have inside, and also delivered and displayed. So basically, this stores all of the applications that you have the desktop notifications turned on for, including the browser. So whenever you're using, for example, some social media website like Facebook or Twitter or WhatsApp, for example, and you allow it to send you these little banners that tell you that you have a new message or notification, that will get saved in this cache. And let's look at the app table. So the app table just lists basically what applications have that permission to display notifications for you. So there's a lot of different weird system things as well. So I just filtered it out in the query, just looking at the database. But you can see this is pretty generic. It's just Chrome, because for a test I just allowed some Facebook and WhatsApp notifications in Chrome, and mail and iChat, which is basically iMessage, and reminders and all of this kind of generic Apple macOS applications. And then in the record table, you can see that you will have basically each row in this is one notification. And there's a number of interesting fields, like the date, and also the data that the notification held, which is probably the most interesting for us, and also the app ID, so you can cross-reference with the app table and see which app has produced this. So for example, here, this is just like a data blob in hex, so you can look at this, but I'll show you how to parse it in a second. So even if you look at this raw data, you can see, for example, someone texted me saying sounds fun, and the contact was called Bill Gates in my iMessage, and you could see it here in plain text without any problem. So whatever you see in the little banner will be saved here. So of course you will have a lot of notifications in a kind of normal scenario, not like my VM that I used for 15 minutes. So you would like to automate it so you don't have to go into each one and manually look at the database. So to be able to do that, we have to look at the format in which the notification is stored. So this is basically like this Python, dictionary. You can parse it as a Python dictionary. I think it's like a property list type, XML typed format, and you can see a number of already kind of interesting things here. it will depend. The things that are in there will depend also on the app that is producing the notification. So this was a web WhatsApp notification, and you can see that in the title field, for example, there's the name of the group chat randomly, but obviously for other apps it could be anything else. I think for mail it puts the subject line of the email that you got, and the body will be whatever was texted to you. And here there's also a date when it was produced, and the date is in the NSDate format, which is some macOS specific date format, I think, but the database kind of viewer, the database browser that I'm using, like lets you just decode it in it, so it's quite simple. And yeah, I was looking at that, and I saw that there seems to be a PNG also saved in the attachment and data part. So it's not always there, but sometimes, when you get a message and there's like a little thumbnail, square image of either the contact who sent you something, or maybe someone emailed you a picture, a photo, or I messaged you a photo, and you can see the little thing. So I found this blog post that on the Objective-C kind of macOS security blog about signal messages, and they had this kind of nice intro script. So I took that script and I added some things to it so that it also carves out the images and saves them, and kind of makes the output nicer. So, whoops, sorry. So you can see I just kind of identified the app body and title. Obviously it will be different for different apps, so there could be more work put in it. But whenever there was an attachment, I saved the image, saved the image in a file. So then I was able to actually get an image which was the icon for the group chat in WhatsApp, and I had very little data, so I only got one, but I tried on my personal computer, and I got a number of different pictures, including some that were emailed to me. So that was pretty scary. And also another, I think just the generic Apple Mail app has saved the whole email in the notification cache, even though obviously the whole text is not displayed, but somehow the whole text of the email, which had like 2 paragraphs, was saved there. So yeah, that wasn't the best. Yeah, so there's a number of questions, if anyone is interested in this, that I have not solved, and that would be very good to find out how long do the notifications persist, because I can see them disappearing after a couple of minutes from some apps. From some apps they are left there, so probably you should, the best way it would be to save it every, I don't know, X minutes or seconds somewhere, so that you always have the most up-to-date ones, and then you can kind of, using the dates, kind of build a timeline. And also, how are all of these things and their behavior influenced with how you interact with the notifications? So if you click reply, close, or whatever. So these are things to find out that I haven't yet. So you're welcome to look at it as well if you're interested. And yeah, thank you. I think that's all. This is a QR code for my blog where I will put the slides, and there are already some resources about this there. So I don't think we have time for questions, so just catch me after if you want to ask anything. Wait, oh, there is time for questions. Okay. So if you have any questions, I'm happy to answer. No? Okay, then thank you very much. Thanks.